Hey everybody, one of the projects I've been working on is trying to make an RC car. It started with me trying to make a drone from scratch. However, I quickly realized that these brushed DC motors that I got were too heavy for it, and that I would need brushless DC motors. But then I wouldn't be able to just buy a bunch of components like this and build it out. So I changed the project I was working on to building an RC car instead. So there are just some of the components. So we have an Arduino that sends a signal to control the motor. There's also a battery pack right here. This battery pack powers the motor itself. And then we have some circuitry here. So the diagram I have on LT Spice in front of me, it is one of these rows. So this can control up to 4 motors, and we're just gonna try breaking down one of these rows that control the motor. So let's just break down the circuit right here. We have our V signal, and our V signal comes in, and first thing you see over here is we have a pull down resistor, and we have a inline gate resistor. So the pull down resistor just makes sure that this point right here is at 0 if the signal has nothing coming in. So it just makes sure that the off state is actually 0 volts. The inline resistor here, there are several reasons to put a resistor right before the gate. It prevents any ringing from occurring, since there's a capacitor right here at the gate, and you can have parasitic inductances. It also makes sure that it smooths out the transient effects of our signal. So we are controlling this motor using pulse width modulation, which sends a series of square waves to our component right here, the NMOS component right here. And having a resistor and capacitor in line like this, it would just help us smooth out the curve a little bit, so you don't have these very sharp spikes in current or voltages. On the other side is this is the circuitry that can actually powers the motor. So the way this works is, if this V signal is at 0, this means that the transistor here is in off state. This off state means that this point right here, the V motor N, is going to be at the same voltage as V motor P, and there's no voltage drop across these points, and so the motor will not drive. However, when we send a on signal, this would connect V motor endpoint to ground, which then means that there is a 12 volt drop between the V motor P and V motor endpoint, and that voltage drop is what's going to drive our motor between those 2 points. In between, we have a capacitor and a flyback diode. The capacitor just helps smooth out any of the high frequency components coming from our our power source right here. It shouldn't be a big concern since we are using a battery, but this is one way to mitigate high frequency components that may make our motor rattle. We also have a flyback diode right here. The reason to put this flyback diode is we have our motor spinning between these 2 points, and when we stop the motor, it is still an inductor, so this is going to cause a voltage spike to occur. And if the voltage spike occurs and we don't have a flyback diode here, the spike is just going to damage our NMOS component. So by having a flyback diode here, it just ensures that if there is a voltage spike, there's a path for the current to go through back to the motor, instead of going to our component right here, the NMOS component right here. So let's just run this. So the way it's set up right now is at startup, everything is at 0, and all our components are going to charge up. In this case, the capacitor, for example, is going to charge up as well. And after that, we're going to send a pulse where the first 5 seconds it's at 0, and then the second 5 seconds it will be at 5 volts. So sorry, the other way around. So it's at 5 volts initially. So we can see that when it's at 5 volts, we get the voltage at the motor N to be at 12. So there's going to be no voltage drop. As soon as we send our signal over here to be 5 volts. So it's at 0 volts, meaning the voltage at this point is 12. When we send our signal, it's 5 volts. Then the voltage over here is going to drop from the 12 volts to 0 volts, and it would actually have the motor just spin. So we're going to see what that looks like over here on the Arduino. So I have some Arduino code that's already uploaded. This all it does is it gets the motor to speed up, and then it gets the motor to slow down every 10 seconds or so. So let's just wire everything up. So in this case, the green wire is ground. The blue wire is our signal wire. And this is our motor right here. So as soon as I plug it in, as soon as I power the motor up, it will start working. So I'm just going to put the pins from battery to the power rail. And I will connect the Arduino, so the Arduino is powered. So this should that's fine. So you can hear the motor spinning. And we have the motor spinning right now. It's hard to see it. Maybe able to show it using a piece of paper. Nope, it's hard to show it visually since I don't have a something at the end of this motor to show it spinning, but I hope you can hear it. And that's just a little intro to what I'm building and how it works. My goal with next thing with this is going to be, I want to print out some parts to actually house all these components in a container that's 3D printed, and also I want to 3D print some wheels for the motors as well. And I want to also add a sonar component as well, so it's able to use signals from a sonar component, which you can buy online for Arduinos, to start and stop based on whether there's an obstacle in front of the car or not. Well, thank you so much for listening, and if you have any questions, feel free to reach out anytime. Thank you.